Operators in Java. Arithmetic expressions in Java. This is also called arithmetic operators. You have addition operator, you have subtraction, you have multiplication, division, and modulus. This is the remainder of division. Let me give you an example. Say integer result is say 10 plus 3 and print result. So guess what will be the result? Java 13. So you know this from elementary school. It is very simple. Then you have subtraction, and then you have multiplication, and then you have division. That is the interesting one. This is 3. 10 divided by 3 is 3. So the division of a whole number by whole number is a whole number in Java. What if you give here float? So 3.0, that's the only difference. As you have noticed, the result of this division is not accurate. 10 divided by 3 is kinda 3.33 or something like that. But because we are here using integer and also here whole number, we get wrong result. So for that we need to convert this to double. To convert or cast one value or variable from one type to another type, one way is to use brackets and then the name of the type, for example double. The same thing we should do here, double, and then we see compilation error because this one is integer, the left side is integer and the right side is double. So this is an expression. What is an expression? An expression in programming is something that produces a result, that produces a value, a final value. So this expression produces a value that is type double, but here we declare integer. And that's why we see here compilation error. So we must also change this to double. Now let us see. Very interesting now. So when it was integer, it was 3. When it was float, it was 3.0. But when it was double, it is 3.333 and 5, which is much more accurate than the previous one. So you see that using the right type, the correct type, is also very important in programming. There are some useful terms here. So this one is called operator, and the values are called operands. So this is operand, and this one is also operand. There are also some other operators in arithmetic, that is increment operator, then you have decrement operator, then you have a shorthand operator for division, like this one, and then you have a shorthand operator for multiplication. Let me give you an example of that. Let us say we have here integer x 1 and we want to increment this by 1. Let us say x here is 1 and we should see something different than 1. So we see 2. So this one plus plus increment a value by 1, and minus minus decrement a value by 1. Now it is 0. It was 1 is 0. You have shorthand for division, multiplication. You also have shorthand for addition and subtraction, that you have this one and you have also this one. So instead of that, you can use plus, let's say 11. This means x plus 11. This one is a shorthand for this, that you at the same time reassign the value of a variable with a new value. Let us see. For the increment and decrement operators, you have also another term, prefix or postfix. Let me show you. For example, if we have integer y, x plus plus, and this one is y, you will see a strange result. Why this result? Because here in this line, we first assign the x value, the initial value, to y, and then we increase its value. So its value got increased after it was copied to this variable. And if you here add this before, it is called prefix. So if we apply this as prefix, first the x will get increased by 1, and then it will be copied to y. Now here both x and y will be 2. Voila, 2 and 2. Increment and decrement operators increases or decreases the value of a variable by 1. If you want to increase the value by more than 1, you can use this operator, plus assignment operator or minus assignment operator, as I showed you previously. These 4 operators are also called augmented operators or compound operators. Let us do an example of multiplication. Let's say we have here 7, and we do x multiply by 5, which is in the same as x assignment operator x times 5. This is exactly the same. We don't need this anymore. Take a look. Now 35. So you know from a long time ago from school that 7 times 5 or 5 times 7 is 35. So this one is compound operator or augmented operator for multiplication. Let us do an example of modulus in compound operator. X modulus 5. Let us make this 35 and see the result. It is 0. So the remainder of division, when you divide 35 by 5, is 0. So these compound assignment operators are very handy and short. In Java, you have different categories of operators. You have arithmetic operators, you have assignment operators, you have comparison operators, you have logical operators, and you have bitwise operators. We talked about arithmetic operators and assignment operators here in this chapter. These are arithmetic operators and these are assignment operators. This is also one of the assignment operators that we have seen since the beginning of this course. So now you know arithmetic operators and assignment operators. Let's talk about comparison operators. Comparison operators are used to compare two or more than two values, to evaluate the equality of two or more than two values or variables. Let me give you an example. In comparison operators, you have double equal sign for checking the equality, then you have right angle bracket for checking greater than, then you have left angle bracket for checking less than, is A less than B, and then you have greater than and equal to, then you have this one for less than or equal to. Integer x, say 5, integer y is say 9, and then boolean result x equal to y. This is called boolean expression because it returns a boolean value. When an expression returns boolean value, it is called boolean expression. The result is false because 5 is not equal to 9. Let us do the greater than. Is x greater than y? Which means is 5 greater than 9? Again false because 5 is not greater than 9. It is check for less than. Is x less than y? The result will be true or false. Let us see. True because 5 is less than 9. Let us check another one, greater than and equal. Is x greater than or equal to y? Let us check less than or equal to. True. Is x less than or equal to y? Which means is 5 less than or equal to 9, which is true. Now this is a very simple and easy expression. In some situation you can have expressions like many lines. It doesn't matter how big the expression is, it works the same. If you understand this, you will understand no matter what big expression you get. There is also one more operator in comparison operators, and that's not equal to. Let us check. This expression means is x not equal to y. It is true because 5 is not equal to 9. What if you want to combine multiple Boolean expressions? Here you want to add also directly a value, not a variable, like say 2 greater than 7, and you want to add another one, 8 equals to 2 times 4. Now we see error. How to resolve this error? So for this we need logical operators. In logical operators you have three operators. You have AND logical operator, you have OR logical operator, and you have NOT logical operator. Let me give you an example. Boolean result true and false. Suppose this is a Boolean expression and this one is another Boolean expression, and we use a logical operator to evaluate the result of two different Boolean expressions. Result false, true and false is false. Let me change this to false. False is also false. False true is false. True is true. Let me recap here. Let's say T for true and F for false. If there is one false in your expression with AND logical operator, the result is false. There is something very important about logical operators that almost nobody talk about, and that is very important for junior developers, for junior programmers. That is that AND logical operator searches for false. If there is one false, it stops and it will not evaluate the rest of the expression. For example, if I turn this to false, you see here a warning, date code. So it found false here, and this is AND logical operator. This one is date code, which means that it stops here. It will not go further. If you understand this, you will not write unnecessary code in your application, in your program. So now this one is completely unnecessary. Let me give you now an example of a OR logical operator. Change this just to this one. The OR logical operator searches for true. If it finds one true, it stops there and it returns. So if I change this to true, even this one is true, it says date code, which means that the expression stops, the compiler stops here and it returns the result, which is true. If this is false, so it is very important that you get the concept of logical operators. And logical operator searches for false. If there is one false, it returns false. Even if there is 100 truths, but there is one false, it returns false. And the OR logical operator returns true if there is one true. Even if there are 100 false, it returns true if there is one true. It will stop at the point where it found true. It is very important later in your code that you should not write unnecessary code, because it makes your application heavy and difficult to maintain, to extend, to update, to upgrade. So these are tips from my years of experience. I made these mistakes at the beginning of my career as a software engineer. So when I started learning programming like 15 years ago, nobody told me this. I learned this stuff by experience in a hard way. So it is very important, and I want to share you all my experience in all my tutorials. I wish somebody told me this stuff when I started learning programming. Back then, there were not so many tutorials on YouTube or online. We had to use books, and we had local training courses and local trainers. They were just looking for money. That was the most important thing for them. They were teaching just that general stuff without going deep, without concentrating on deep stuff, like to understand the concept of logical operators, comparison operators, and writing clean code, writing short code. I wrote some stuff here for you that you can read. Then we have not logical operator. So this one is true. If you use not logical operator, the result will be false. False. If this is false, the result will be true. So not logical operator reverse the result of the whole expression. If it is false, it turns it to true. If it is true, it turns it to false. Now that we know about the logical operators, let us come back to this one. So here we got error because we combined multiple Boolean expressions. So let us say x not equal to y and 2 greater than 7 or 8 equal to 2 times 4. By default, any programming language evaluates any expression from left to right. Now for us, this is 3 components, but for compiler it is 2 components, this one and this one, and the result of this one will be the result. Let us take a look. Now it is true. Let us see why. So this one is true, and the result of this is also true. True and true results to true. 2 is not greater than 7, so this is false. But 8 is equals to 2 times 4. You can do many stuff and combine them with comparison operators and logical operators. But if you understand the basics, they are all the same. Let us say you have a very complex expression. You have a combination of 100 Boolean expression. The first 99 expressions are true, and there is one false expression at the end. By default, the compiler will go through all 99 and stop at when it reaches the false, when you are using the AND logical operator. But if you bring the false at the beginning as the first expression, then it will stop immediately and the false at the beginning and ignore all the other 99 expressions. So now you see the difference, and I hope now you understand how it can impact the performance of your application. And the same way, if you have 100 expressions and you are using OR logical operator, and the first 99 expressions are true and there is one false, so the first one is true, it stops there, returns true, and ignore the rest. You can also wrap them in parentheses to negate the whole expression. Let's see. Now it is false. Before it was true. Another side note about not logical operator. For junior developers, you immediately think about AND or logical operator. But non-logical operator is more useful than other two logical operators. In many cases, not logical operator is shorter, easier, and more professional. So whenever you work with Boolean expressions, think about not logical operator as well, because it helps us to write very clean code and short code. Not logical operator help us to avoid many complexities. I hope that comparison operators and logical operators were clear for you and you understood the concept of comparison operators and logical operators. Now let us talk about bitwise operators. You have all these operators in bitwise. You have bitwise AND operator, you have bitwise OR operator, you have bitwise exclusive OR operator, this one. Then you have bitwise complement operator, you have bitwise left shift operator, you have bitwise right shift operator, then you have bitwise unsigned right shift operator. Bitwise operators evaluate the binary representation of anything that you give. First, it converts your input, your value, to binary and then runs binary operators on them. Let me give you an example, and the result is really something shocking. So we say x and y. So the result of bitwise operator is not boolean, it is another integer. Let us see the result. It is 1. So doing 5 and bitwise operator with 9 is 1. To understand this, we have to convert 5 to binary and then y also to binary and do some AND operator. So what is 5 in binary and what is 9 in binary? Let me show you how you can convert from integer to binary. So binary numbers are series of zeros and 1, that is called base 2. And the decimal number, the number that we use every day, is called base 10. We have 10 digits from 0 to 9. In binary it is base 2 because you have 2 digits, 0 and 1. One way to convert from decimal to binary is to divide the number by 2 and check the result or the remainder. 5 divided by 2, so you have here remainder. So when you have remainder, you add 1 and then the result is 2. 2 divided by 2 is 1. You don't have any remainder, so you add here 0 and then you have 1 divided by 2, again fraction, then you add here 1. This one is also 0. It is by default. They show the binary in the format of 4 digits for better readability. So the first one is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. So for 2 to the power of 0 we have value, so that is 1. For 2 to the power of 1 we have nothing, that is 2, but we have nothing, so 0, 1. And then for 2 to the power of 2 we have value, that is 4, so here we have 4 plus 1 is 5. This is 5 in binary. Then let us say the 9. So 9 divided by 2, We have again a decimal number. You have to record here 1. 4 divided by 2 is a whole number, 0 on the left. Then we have 2 is the remainder divided by 2. Again 0 at the end, and then 1 divided by 1. 1 divided by 2, sorry, is again decimal number. We store here 1. So now you know this one is 1 to the power of 0. So for that we have value. For 2 to the power of 1, which is 2, we have nothing. For 2 to the power of 2, which is 4, we have nothing. For 2 to the power of 3, which is 8, we have value. So 8 plus 1 is 9. I hope you understand the power stuff from school. When I say 2 to the power of 3, this is the way you say in computer 2 to the power. Double star is power and single star is multiplication. When you say 2 to the power, which means 2 to the power of 3, for example, 2 times 2 times 2, which is 8. So now let us run AND operator on this, and let us see why the result came to 1 in our case, why the result was 1. So for AND, you know from the logical operator, true gave us true, false gave us false, true gave us false, false true gave us again false. If there is one false, you get false. So here we have 1 true for 2 to the power of 0, which is 1, and that is why the result is here 1. If I run this again, Java, operators in Java, the result is 1, and we also found this 1. So this is just for AND. If we change this to OR bitwise operator, the result will be, so this one and this one is 1, true is true, false is false, true false is true, so we have to add here a 1, and false true is true. So here we have 8 4 is 12 plus 1 is 13. We should get here 13. Yes, now here is 13. If you don't understand this stuff, don't worry, take this as external note about bitwise operator. So that's enough about AND bitwise operator and OR bitwise operator. If you really like to learn all these bitwise operators, I talked about bitwise operators in details, very deep, all of them. I explained all of them with multiple examples in my Python full course. I put the link in the description of this video so that you can jump right to the section where I talk about operators in Python. So operators are the same everywhere in all programming languages. So only if you are curious about bitwise operators and you like to learn all of them in details, you can go there and watch the course. Now you also learned how to convert from decimal to binary. And to convert from binary to decimal, it is very simple. From right to left, we have 2 to the power of 0, which is 1, plus, for the 2 to the power of 1 we have nothing, so plus 0, and then we have plus 2 to the power of 2, which is 4, so plus 4, and then for 2 to the power of 3, which is 8, plus 8. So So you add these numbers together and you come up with 13 as the result. This is how you convert from binary to decimal. I hope everything was clear. Order of operations in Java. The order of operations in programming languages are the same. In all programming languages, order of operation is the same. So when you learn it in Java, you learn it also in another programming languages. Take a look at this example. So 10 plus 3 times 2. What will the result be? The result will be 16. It is a basic math that many people misunderstood, and they think that this is 10 plus 3, which is 13, and then times 2, which will be 26. But the order of operation is different. Multiplication and division have the highest priority in operations. So the compiler will first do the division and the multiplication, and then the addition and the subtraction. Take a look. The result is 16 instead of 26. We can change the order of operation. If I do this, then it will change the order of operation. Now it is 26 because 10 plus 3 is 13. 13 times 2 is 26. So whenever you want that some parts of your expression get evaluated first, you need to wrap them in parentheses. That way the compiler will evaluate those parts with parentheses first and then the rest. So this is the summary of order of operation. Parentheses have the highest priority. The compiler will do first everything that is inside parentheses, and then it will look for multiplication and division, and finally for addition and subtraction.